welcome to this session. This session, we are going to introduce the concept of the Jacobians. And the assumption taken for this chapter is that you are very well grounded in linear algebra, specifically for properties of determinants, how to evaluate the determinants of square matrices, how to manipulate or play with trigonometric hyperbolic functions, all types of functions, and how to prove some results using determinants. So my advice will be that if you are not well grounded in determinants, properties of determinants, and some basics on functions, please watch the videos on linear algebra before you start watching these videos. So as I say, the ingredients for you to understand Jacobians, you have to understand determinants, properties of determinants, and then functions, especially how to play with trigonometric, hyperbolic, and polynomial functions, and then knowledge on partial differentiation, and then systems of linear equations. So how to know whether the system of linear equations has solution or has no solution. So these are some of the things that will help you to have an easy sailing in this chapter. But you shouldn't worry. If you have not done these chapters, feel free to watch videos on linear algebra, which has most of this stuff. This one is in calculus. This is still in linear algebra. So therefore now let's introduce or let's give the definition of the Jacobian before we do some examples. So definition of Jacobian. So if U and B are functions of two independent variables x and y, then the determinant is determinant partial u, partial x, partial u, partial y, partial b, partial x, partial b, partial y is called the Jacobian of uv with respect to x and y. and is written as partial uv partial xy, or we write it as j u comma v and then x comma y. So that's how we define Jacobian of two variables u and v with respect to independent variables x and y. Similarly, you can define Jacobian for three variables. Similarly, the Jacobian of u, v, w with respect to x, y, and z is partial u, v, w, partial x, y, z, which can as well be written as j, u, v, w, x, y, z, is given by the determinant this 3 by 3 determinant, partial u, partial x, partial u, partial y, partial u, partial z, partial v, partial x, partial v, partial y, partial v, partial z, partial w, partial x, partial w, partial y, partial w, partial z. So that's how we determine or we define Jacobian of three variables x, y, Jacobian of three variables u, v, w with respect to x, y, and z. Now, we may also define the Jacobian of x, y with respect to u, v as, so we write this one now, x, y, then u, v, which is the same thing as writing partial x, y, partial u, v, and this will be the determinant, partial x, partial u, partial x, partial v, partial y, partial u, partial y, partial v. And similarly, the Jacobian of x, y, z with respect to u, v, w is determinant, partial x, partial u, partial x, partial b, partial x, partial w, partial y, partial u, partial y, partial b, partial y, partial w, and then partial z, partial u, partial z, partial b, and then partial z, partial w. So in the next session, we'll do some examples on how to define Jacobian of some functions. Thank you.